Right, good day. Welcome to your last AP Math lesson. Okay. Again, we're working from Mind Maths, Calculus and Algebra. We're doing question 2b on page 119. We're continuing with Ln and E graphs. Okay. So, in the first question, you've got f of x is equal to ln absolute value of x plus 3. Just by the way, we're going to not work in E form, we'll give coordinates to one decimal digit. And the first question says, go find the vertical asymptote. Okay? Right, so that's pretty straightforward. Vertical asymptote will be where that's equal to 0. So it's where x plus 3 is equal to 0. So therefore, x is equal to negative 3 is your vertical asymptote. Right. Now your domain, in order to sketch it, we've got to find the domain and the intercepts. I don't explicitly say domain, but I would always look at domain if I'm working with log graphs. So the domain will be when that whole thing over there, absolute value of x plus 3, we want to know when that's going to be bigger than equal to 0. Well, it will always be bigger than equal to 0. Bigger than 0, except for when x is equal to negative 3. So the domain is going to be x can be anything, but x can't be negative 3. So there's your domain over there. Right, go quickly find your intercepts, go find your x-intercepts, go find your y-intercepts, if you haven't done that yet. Right, so the x-intercepts, we let y be equal to 0, so I get 0 is equal to the ln absolute value x plus 3. Okay, so if you're more comfortable still writing it as log e absolute value of x plus 3, you can. And if I change that to exponential form, I'm going to get e to the 0 is equal to absolute value of x plus 3. So 1 is equal to absolute value of x plus 3, which implies that x plus 3 is equal to 1, or x plus 3 is equal to negative 1. Okay, so x is equal to negative 2, or x is equal to negative 4. And they ask you for the coordinates. And if they ask you for the coordinates, then you've got to write down the coordinates of your intercepts are negative 2, 0, and here, sorry, it should be negative 4. Negative 1 minus 3 is negative 4, and negative 4, 0. So they're my x-intercepts. Okay. Your y-intercept, well, if you let x be equal to 0, you get y is equal to ln absolute value of 0 plus 3. In other words, y is equal to ln of 3, and ln of 3 is, if I'm not mistaken here, ln of 3 is 1, 1. So your other intercept is 0, 1, 1. Right, so now you're going to use your intercepts, your vertical asymptote, and your domain, okay, and go sketch that graph. Okay. Okay, now if we sketch a curve, we worked out where the vertical asymptote x is negative 3. Okay, then we had intercepts at negative 4, 0 and negative 2, 0. Y-intercept at 0, 1, 1. And if you use symmetry, well, it's 3 across to get there. If I go another 3 across, I get to negative 6, and then the y values must be the same. So it's going to be negative 6, 1, 1. You can check that if you want. So then your actual graph is going to go, voila, it's a log graph, it's going to flatten out. And head towards the vertical asymptote. And look something like that. So this is the graph of f of x is equal to ln of absolute value of x plus 3. Mark, 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 shape, blah, blah. Everything must be labeled, guys. Okay, that's the deal. Just check you got that. The last couple of questions with 2b. Right, they first didn't ask you what's the domain. Well, we worked that out earlier. The domain is anything except x can't be equal to negative 3. And the range, you can see, you can have any y coordinates. The range is y is an element of reals. Okay? Then it says, determine the values of x in question 4 for which f of x is less than or equal to 0. In other words, your y coordinates are less than or equal to 0. Okay, so where are your y coordinates on this graph less than or equal to 0? Well, over here. Okay, so and over here. So on the number line, it would be from here, solid dot, open dot, up to there. So your first interval, where the y coordinates are less than 0, are going to be x is an element of, I can include 0, so it's square bracket -4, up to -3 is your x value here, up to -3, round bracket, this is x is -3, so between -4 and -3, this was -2 here, and then there's a gap, and then all we can use a union sign, again from, we can't include -3 because that's the asymptote, okay, and then all the way up to -2, okay, and you can include -2. So when is f of x less than 0? Between -4 and -3, and then again, not including -3, up to -2. Right. And your last question, okay, is when is f of x greater than 0,5? Well, they're saying to you, but that as well as the x coordinate has to be bigger than -3. They put that restriction in because otherwise you'd have another region, two regions where f of x was bigger than 0,5. So we are only doing, okay, this bit over here. Okay, when is f of x bigger than 0,5? So I've got to find the x value that goes with the y value of 0,5. Okay, so I want to know where y is equal to 0,5 on this graph, where f of x is 0,5. So I've got to solve this equation. 0,5 is equal to ln absolute value of x plus 3. So 0,5 is equal to log, you don't have to do this step, e of x plus 3. So e to the 0,5, e to the 0,5 is equal to absolute value of x plus 3, which implies that x plus 3 is equal to e to the 0,5, or x plus 3 is equal to negative e to the 0,5. Well, this solution will give you -3 minus e of 0,5, which is less than -3, and it said x has to be bigger than -3, so we're not going to use that one. So our solution, when y is equal to 0,5, is going to be x is equal to e to the 0,5 plus 3. Okay? And if you work that out in your calculator, you get x is equal to e to the 0,5 plus 3, gives you, hang on, e to the minus 3, sorry, e to the 0,5 minus 3, and e to the 0,5 minus 3 is negative 1,4, that's to one decimal place. So you've worked out that when y is equal to 0,5, the x value that goes with it, over there, x is equal to negative 1,4. So the question was, when is f of x bigger than 0,5? Well, it will be bigger than 0,5 to the right of x is equal to negative 1,4. So your answer for 5 is x is bigger than negative 1,4. That is where your y coordinates are bigger than 0,5. Right, just one last thing I want you to do quickly is, just in case, you've got f of x is equal to ln absolute value of x plus 3. Okay, as you can see, it's got two branches to it, and that's because an absolute value can be written as a split function. So quickly go write f of x as a split function, just as an extra little bonus. As your bonus free question, I just asked you to write that as a split function. Okay, so remember that absolute value of x is x if x is bigger than or equal to 0, and negative x if x is less than 0. What that means is the absolute value of something stays the same if what's inside is bigger than or equal to 0, and it changes signs if what's inside is less than 0. So if you've got f of x equal to ln x, this one over here, if I get rid of the absolute value, will stay the same if what's inside is bigger than 0. So it'll be ln x plus 3 if x plus 3 is bigger than 0. And it'll be change sign, so it'll become ln minus x minus 3 if what's inside is less than 0. In other words, if x plus 3 is less than 0. And if you neaten it up, the two branches, well, this branch will be ln x plus 3 when x is bigger than equal to minus 3. We actually don't have to say bigger than equal to in this case, because there'll be an asymptote there. So it'll be, the function will be y is equal to ln x plus 3 without an absolute value when x is bigger than negative 3, and it'll be ln minus x minus 3 if x is less than negative 3. Bonus question, done. No extra charge. Okay, in question 3, I'm not going to do it with you, but if we just look at 3a, really what we're checking there is that you understand transformations. So you could draw them just by moving, you could plot a couple of points and then move them appropriately. So just check that you understand. In number 1, f of x plus, have a look at on page 119 please, 3a, I'm not going to write them down. Number 1, y is equal to f of x plus 1. Well, compared to the original graph, it'll shift 1 up. 2, f of x minus 1 will shift 1 down. 3, y is equal to change f of x plus 1, which means change every x into an x plus 1. It'll shift 1 to the left. 4, y is equal to f of x minus 1. You should know that that'll shift it 1 to the right. In number 5, y is equal to negative f of x, which is the same thing as negative y is equal to f of x. The y coordinates have changed signs. So 5 will be a reflection of the original graph about the x-axis. 6, every x has changed into a negative x, so it's flipped over the y-axis. So 6 will be a reflection of the original about the y-axis. 7, well, you've done two transformations there. Okay. First of all, you've flipped it over the x-axis. Okay, but then you have kind of flipped it back by making it the absolute value. So everything will end up being above the x-axis. 8, you've flipped across, you've transformed, first of all, f of negative x. You flipped it over the y-axis, and then you're going to make sure that everything is above the x-axis. 9, it's the original graph reflected below the x-axis. Okay, and 10, there's a double transformation there. You can go play around with that. It's reflected about the y-axis. Pulled above, then all pull below. Okay, so just as long as you understand the transformations for question 3, you can go draw them for 3a and b if you want, and the memos are going to be posted. Right, we're going to go on to C, question 2 on page 120. Right. So, in question C2, we're adding a couple of little extras. The base of the question is this. We've got y is equal to log 4 16 minus x squared. We'll be dealing with that function. And I want you to do the following. First of all, I want you to go find the asymptote, okay, the vertical asymptote, and then I want you to find the domain, and then I want you to find the intercepts. Okay, go try to do those three things. Right, so the asymptotes will be when 16 minus x squared is equal to 0. And that bit is equal to 0. So when x squared is 16, so there'll be two asymptotes at 4 and at negative 4. So those are going to be your vertical asymptotes. Right. The next thing. Okay. What's the domain of this function? Well, the domain will be when that thing inside the log is bigger than 0. So your domain is going to occur when 16 minus x squared is bigger than 0. So in other words, if we divide by a negative, when x squared minus 16 is less than 0. Divide by a negative, the direction of the inequality changes. Okay, and that factorizes to x minus 4, x plus 4. And if we think of this is a positive parabola, okay, the intercepts are going to be at negative 4 and 4. And we want to know where the function is going to be less than 0. And the function is less than 0 over here. In other words, between negative 4 and 4. So your domain is going to be x is an element of negative 4 to 4, not including your end values. Okay? Right, there's a domain. And so it's stuck between those two values. There's your vertical asymptotes. Okay? And lastly, your intercepts. Well, if I let x be equal to 0, well, go work out your intercept quickly while I'm sorting out my pens. Okay. If you let x be equal to 0, bollocks. if x is 0, we're going to get y is equal to log 4, probably can't see that, of 16 minus 0, which is log 4 of 16. What does that mean? 4 to the what is 16? Well, 4 to the 2 is 16, so y is equal to 2. So your intercept is at 0, 2. That's your y-intercept. Okay. Then we need to go find your x-intercept. Okay. And for your x-intercept, nice pen, we want to solve the equation where 0 is equal to log 4 16 minus x squared. Log 4 16 minus x squared, am I right? Yep. So then if I rewrite it in exponential form, I want to know where 4 to the 0 is equal to 16 minus x squared. So in other words, where 1 is equal to 16 minus x squared, so x squared is 15, so x is equal to plus or minus root 15, and if you go do that to one decimal digit, I think you get x is equal to plus or minus root 15, we're going to get blah 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 blah, apologies for delay, plus or minus root 15, we get plus minus 3,9. Sorry about that. X is equal to plus or minus 3,9. So my intercepts are 3,9, 0, and negative 3,9, 0. Okay? Right, so that's going to be important. Okay, we'll summarize all of it just now. Okay, the last thing I want you to do is if I said to you, what's the maximum value of this function? Okay, and this is a bit new and you're going to have to concentrate. Well, we're working with a log base 4. And a log base 4, okay, is an increasing function. Okay, it's going left to right up. So the bigger x is, the bigger y is. So if you've got log f of x base 4, the bigger x is, the bigger y is. So the maximum is going to occur if you've got log f of x base 4. When this is at its maximum, the whole log graph will be at its maximum. So the maximum is going to occur when f of x is maximized. Okay? In other words, when, what was in this case, it was log 4 16 minus x squared. So the maximum value of the log is going to occur when 16 minus x squared is maximized. And if you think of the graph 16 minus x squared, it's negative x squared plus 16. It turns at 16. So the maximum value of this function is of 16 minus x squared is 16, and happens when, that's the key idea, when x is equal to 0. So this whole function will be maximized when x is equal to 0, because that's when this inside bit is at its maximum. Okay, so the maximum of the log function, if I replace x with 0, will be equal to 2. So 0, 2 is not only your y-intercept, it's also 0, 2 is your maximum value. Right, so I want you to combine now all of this information. Okay, the fact that the vertical asymptotes are 4 and negative 4, 0, 2 is your y-intercept and it's your maximum value. The x-intercepts are plus minus 3,9, and the graph is stuck between negative 4 and 4 because that's your domain. Okay, your range will be from the maximum 0, 2, log graphs go down forever, so down to negative infinity. Right, try to combine all those bits of information, okay, and draw that function. I like that kind of question. There's your hint for the day. So if we try to draw this graph, well, first of all, we've got vertical asymptotes at x is equal to negative 4. Okay, label it. And x is equal to 4. Right. Then we've got a maximum, this graph will be maximized at 0, 2, which is over there. That's your maximum value. It's got a turn there. The domain, it's stuck between those two values. The x-intercept, the one is at 3,9. And the other is at negative 3,9. So it's just going to end up looking like a flattened out parabola. And yep, we've got all the information we need. So it does something like this. Okay. And like that. If you want to choose a few other values, at x is 2, x is negative 2, okay, and you'll see that is the graph you get. So the range, okay, I think they asked that somewhere as well, y goes from negative infinity up to and including 2, domain negative 4 and 4, etc. So the key idea to find the maximum value of a log is where what's inside the log is maximized as well, because it's an increasing function. By the way, in the memo, that answer is wrong. I've got this pointer as 16. I promise you it is 2. Okay. Okay. The next question I want to do is C4, but just what they asked in the textbook, which is you're given the function y is equal to ln e squared minus x squared, and find the domain and the range. You can ask to sketch it or find anything else. Well, the domain is going to be when, well, give that a go if you haven't tried it yet. Domain is going to be when e squared minus x squared is bigger than 0. So when x squared minus e squared is less than 0. So when x minus e, x plus e is less than 0. So you've got a parabola which has intercepts at negative e and e. When is it going to be less than 0? Well, it's in that region over there. So it's going to be on the number line. If you read it off, it's between there and there, between negative e and e. So your domain is going to be x goes from negative e to e. Okay, so again, this will be stuck between your vertical asymptotes. Okay. Then the range, okay, well, it's a log graph. Okay, so we want to figure out, is there going to be a maximum value? And so the maximum is going to occur when e squared minus x squared is maximized. Why is that? Because a Ln graph, a log graph base e, is an increasing function. Okay, so again, when that's at its maximum, the bigger the x value, the bigger the y value. Okay, so the bigger the thing that goes into a Ln function, the bigger the thing that comes out. So when this is maximized, when e squared minus x squared is maximized, the whole Ln graph will be maximized. And if you think of just the graph e squared minus x squared, well, we can think of it as it's negative x squared, it's a negative parabola, plus e squared. So it's a negative parabola which turns at e squared. So the maximum value is e squared. So that's when what's the maximum occur, it's maximized at e squared, but when does that happen? That happens at, if you look at the graph, okay, at x is equal to 0. Okay, so we maximized at x is equal to 0. The question is, what's the maximum of this graph over here? So the maximum will occur when x is equal to 0. So the maximum will be y is equal to ln e squared minus 0 squared, and y is equal to ln e squared. So y is equal to 2 ln e. Okay, and ln of e is 1. So the maximum will be y is equal to 2. So your maximum is y is equal to 2. Okay, and the range, so your range would be of this whole function, then e squared minus x squared, your range will go from negative infinity up to 2, or you can say y is less than equal to 2. Just out of interest, the graph would look like this. You've got negative e, you've got e, it turns at 2. It's very similar to the last graph we did. And it would go through there, and go through there. Okay, that would be your graph of y is equal to ln e squared minus x squared. The idea, the log graph will get maximized when what goes into the log function is positive. Right, hope that makes sense. Get that down, and we're nearly there. Okay, last video question of the term. Okay, and the questions say to you, okay, you're given a formula for how many words per minute somebody can type, okay, and T is the number of days they've been spending practicing. So obviously the number of words proportional per minute to how many days they practice. And the first question says, how many words per minute okay, will they be able to type after 5 days? Well, after 5 days, we've got t is equal to 5, so we're looking for y of 5, which will be equal to 120, just sub in 5, 1 minus e to the negative 0.15 times 5. So I've replaced t with 5, and if you enter that into your calculator, you get y is equal to, let me just check, 63. Okay, so later on in the question, which is nearly always the case, they're going to ask you to draw this function. So let's start writing down some points that we've got. They may be helpful, save us a little time. So the first point I've got is the point 5 and 63. Okay, that's t, that's y. Okay, t is the number of days practicing. So after 5 days, she's typing 63, or he, words per minute. Okay. Right, the next question, so that was that question, says how many days will it take her so that she can type 100, he, it, whatever, can take 100 words per minute. So here, they're giving us y. So they're telling us y is equal to 100, and we've got to substitute in that equation, so it's a bit more work here. So you're going to get, therefore, 100 is equal to 120, 1 minus e to the negative 0.15 t. Okay? So you've got to just go solve that exponential equation, which you should be pretty good at doing now. So you can punch in numbers in your calculator, it might be easier. I'm just going to do it all in one step, and then enter the calculator work once. So you're going to get 100 over 120. I'm going to divide by that. Okay, then I'm going to move the 1 across. So minus 1 is equal to negative e to the negative 0.15 t. Now if I swap around, I get e to the negative 0.15 t is equal to 1 minus 100 over 120. Okay, 100 over 120 divided by 10 is 10 over 12, and 10 over 12 is equal to 5 over 6. Okay, is that right? 10 over 12 is 5 over 6, just makes it prettier. Okay, you don't have to do that though. Now you're going to change it to a log equation base e. So log base e of 1 minus 5 over 6, okay, is going to be, just by using the definition, is negative 0.15 t. So t, if I divide, is going to be ln 1 minus 5 over 6 divided by negative 0.15. So you're going to get t is equal to, shove that into your calculator, and you should end up with t is equal to 11.945. And so to the nearest day, it's pretty safe to say that it took her 12 days, him 12 days, okay, to type 100 words per minute. 12 days to type 100 words per minute, so we may as well add another point. So 12 days, after 12 days, they were typing 100 words per minute. So I've got 2 points for my graph, 5 and 63, and 12 and 100. Right, check that makes sense.
The whole year?
Yeah, there you go, recording.
Oh, hello.
Say goodbye. Right. Okay, so we've got the thing, word per minute typed is equal to that formula. Okay, so we worked out that 5 days, they took 63 words per minute. 12 days, we're typing 100 words per minute. And now we're asked to sketch that graph. Well, the first thing I'm going to have to figure out is what's the horizontal asymptote. Okay, it's an exponential graph, it must have a horizontal asymptote. Okay, so it's not visible at the moment, but if I times that out, I get y is equal to 120. Okay, I'm going to just do this, sorry. Y is equal to negative 120 e to the negative 0.15 t, I'll just distribute that, plus 120. So that, okay, is your vertical shift. So your horizontal asymptote is y is equal to 120. Okay. And what does y represent? The maximum, number of words per minute. So that's telling you that your maximum number of words per minute that this person is capable of is equal to 120. Okay, they can't get beyond that. As t tends to infinity, it doesn't matter how much they practice, the maximum number of words per minute they're going to be able to do is 120. Right, before we can draw the graph, we should also just check when t is equal to 0, after no days of practicing, how many words could they type, and y would be, so just replace t with 0, 120, 1 minus e, well, negative 0.15 times 0 is 0, and e to the 0 is 1, so you're going to get y is equal to 0. So 0, 0 was your starting point. So this poor person, at the beginning of this experiment, couldn't even type one word in a minute. So, pretty sad. And pretty impressive that after 12 days, they've gone up to 120 words per minute. Right, so that's enough information to draw the graph.
Per minute?
Per minute. Okay, so now, no, pretty impressive. So now we can go draw the graph. Off you go. And again, it doesn't have to be a work of art. We've got just, your axes will be t in days. And here, your y will be words per minute. And we've got a horizontal asymptote at 120. So draw that in. There's y is equal to 120. We're on our last sum, Madam Violin.
Yay!
Okay, 120. We also then have some interesting points going on at 563. So let's just make that 60. The number of days we're going to look at is 5 and 12. So let's go 5, 10, 15. Okay, something like that. Okay. And then after 5 days, the person could type 63. So 563 is a point on the graph. It goes through the origin. And after 12 days, they could type 100. So it's going to go through 12, 100, and then it's going to head towards your horizontal asymptote. So voila, your graph is going to be, look, head towards the asymptote. Must show it's getting closer to the asymptote. And there's your graph. And that, ladies and germs, is that for your videos. Thank you for your patience.
Ladies and germs.
Thank you for your hard work. And please look on your WhatsApp group to see the last bit of things that you have to do for the term. Give them a round of applause, please, Amran. Woohoo! Give me a round of applause. All right. Okay. Goodbye then.
Goodbye.
Do miss all of you human beings.